We're continuing on in this chapter. We left off talking about convection. When you have convection in fluids, what you've got is movement of the parts or the molecules in the fluid from warm to cool. And so what happens is as they heat near the flame at the bottom of the pot, then they expand and rise and form a bubble, usually at the top, and then that cools the surface. And so there's a constant movement of molecules through the pot, and that is another way of transferring heat to the food. Radiant heat is the kind of heat that we normally see in our ovens. It can come from both thermal radiation as well as infrared radiation. It is slower than conducted heat or convected heat. So you may remember our oven and lab. We can put multiple racks of cookies in there. They cook in a fairly short period of time, even when they're very close together. Where at home, if you put multiple racks in your oven and had them close together, the things in the middle might not cook at all, or at least they might not cook evenly. The infrared radiation are different types of heat depending on the length of the wave, and they are on the same spectrum as radio waves and microwaves, and ultraviolet light fit into that category. Grilling and broiling are also dry heat methods of food. As I said before, grilling is where the heat comes from below. Broiling is heat that comes from above. And in these particular things, the position or the placement of food in relation to the heat is very critical. You may have it placed very close during the stage while you're browning the food, but then you may move it a little farther away from the heat so that it has a chance to cook more thoroughly through the food. And you'll notice that broilers can be set at different positions, barbecue grills, as well as char broilers that you might see in a commercial kitchen. Baking can use either radiant heat or convected air, usually in the hot enclosure of an oven. As the surface of the food dries, the browning occurs. Usually it takes a temperature of about at least 300 degrees and sometimes as high as 500 degrees. And from an energy efficiency standpoint, this kind of heating is much less efficient than boiling. But you've got to remember, boiling is not appropriate for every food, so you want to choose the cooking method that's the most appropriate for the food that you're making. And a convection oven, like the one we have in lab that has a fan in it, some of your parents may have convection ovens in their home. This is a way to increase the efficiency of an oven through the movement of the air. You can usually cook at a lower temperature and for a shorter amount of time than in a conventional oven. Boiling is one of the most efficient methods of cooking, and you know that at sea level water boils at 212 degrees. As you saw in a previous slide, the molecules of water heat. As they heat, they rise to the surface, they form a bubble, and then eventually will evaporate as steam. And as you know, if you let a pot boil long enough, the surface of the water lowers, and if you forget about it, conceivably you could boil all of the water out of the pot. If you're cooking at higher altitudes, very high altitudes like in Denver or in other cities that are usually above 4,000 or 5,000 feet, you actually have to make adjustments to recipes and cooking times because food boils at a lower temperature. So the higher the altitude, normally the longer the cooking time. Pressure cooking is another one of my favorite ways of cooking, and we'll do something with pressure cooking in the week that we do meats. A pressure cooker is a sealed container that traps the steam that's generated as the water heats, and because that steam is trapped and doesn't evaporate, it leads to an increase in pressure above normal atmospheric pressure, and it also raises the boiling point. So in a pressure cooker, you can cook something more quickly than you could in an open pot. And I'll talk more about that when we do that in lab. The pressure cookers on this slide, the one in the foreground is the type of pressure cooker we might have in our home if you use one at home. And the one at the back is actually the same, but it's used more for home canning, like if you were canning fruits or vegetables or meat or fish. Simmering is a really important concept. It's cooking at just below boiling temperature, around 180 degrees, just at that point where bubbles are rising to the surface and creating sort of a perimeter of bubbles around the pot, but yet it's not that vigorous rolling boil with lots of large bubbles. It's the recommended way of cooking most foods that you're going to cook for a long time on top of the stove, meat items in particular, legumes, because it cooks them effectively without drying them out or making them tough. So again, if a recipe says to simmer, you want just small bubbles to be breaking the surface of the pot rather than the kind that you would see if you were actually boiling a food like the macaroni we saw on an earlier slide. Steaming is a popular method of cooking food both in homes and in commercial environments. The steamer you see on the top is something like that you might see in a home kitchen. The steamer on the bottom is a commercial steamer that is filled with perforated pans. You can cook multiple different kinds of food in a steamer like this. Steam is generated either from a steam plant or there may actually be a steam boiler that's connected directly to the machine. It's, there's a large amount of energy that's released when the steam comes into contact with the food, and so it cooks the food fairly quickly with really limited damage to heat-sensitive nutrients. Pan frying and sautéing are dry heat methods of cooking where you have conduction of heat from the pan to the oil and ultimately to the food. You'll notice in this image that the pieces of food are small. That works well with pan frying or sautéing because you don't want to leave it exposed to the oil for a long period of time, and so you get even distribution of the heat and quick cooking. And it's also a method that promotes browning. Deep frying is another dry heat method of cooking. Here you use oil that's deep enough to completely cover the food. The oil is usually at a temperature of at least 350 to 375 degrees. And again, the heat of that oil dehydrates the surface and browns it effectively. And that's how you can drop in a white, uncooked potato and come out with a beautiful golden French fry. Microwaves are electromagnetic waves that cause a stirring of the polar molecules in the food that are, again, primarily water. Things like air and glass and plastic are not affected. Microwaves penetrate to a depth of about 1 inch in the food, and it's fairly efficient for small pieces of food, but it does cause drying of the texture because of the movement of those water molecules. And it's also not very effective for foods that are really, really thick, because then it has to rely on the conduction of the heat that's formed in that outer layer, and that's why sometimes foods don't cook evenly in a microwave, but it is great for some things. Ceramics are used extensively primarily in home food service. They're not used as extensively in institutional food service simply because they break and they're not as durable. But they're good because they don't react with the food. You can use any type of food product in these. They're great for oven baking and roasting. They're generally not recommended for the application of direct heat. You normally don't see ceramics placed directly on a burner. There are some that are treated with boron oxide. Pyrex and Corningware are well-known brands that treat the ceramics with this particular compound to help them resist rapid changes in temperature and the kind of breakage that might occur when you pull a ceramic product out of the oven. Enamelware is very popular. It's becoming even more popular now. We see cast iron pots covered with beautiful red and green and blue enamel. Probably Le Creuset cookware is the most well-known, also some of the most expensive, but I've noticed that Target and Costco are producing their own brands of enamelware that are really very good quality for just a fraction of the price. And again, it's a glass enamel product that's fused over the top of an iron core that creates an even diffusion of heat, but protects the food from contact with the metal, protects the metal from oxidizing or rusting when it comes into contact with food or moisture. It retains heat very effectively because it is a poor conductor. It does conduct heat, but not as quickly as you might with an aluminum pot or a stainless steel pot that you put directly on top of the stove. Aluminum is used extensively in the institutional world and the retail world of food service. It is usually alloyed or combined with manganese and copper. It is used so widely, one, because it's lower in cost than most of the other materials for equipment. It conducts very effectively. It's lightweight. The downside of aluminum cookware is that it is reactive unless it's anodized. And in the two images I gave you on this slide, the top picture is a traditional brand new aluminum pot before anything has been cooked in it. The one on the bottom is a Calphalon or Anilon type pot where it has an anodized surface, an electromagnetic, electrochemical treatment that's applied that changes that outer surface so that it is actually non-reactive. What you'll notice on the aluminum pots that we have in lab is they've sort of shaded in color. You'll see spots on them. It doesn't mean that they're soiled. It just means that there has been reactions with previous foods, and that's really the only downside of an aluminum pot. Great for boiling water and really for preparing a lot of different foods. Copper goes back historically to the very beginning of tool making. It is known for its excellent conductivity. It is very expensive, and that's why a lot of times copper is just used as an inner core or as a liner on pots rather than to make an entire pot. The downside is that it is expensive and that it's hard to maintain if you want it to look nice. It'll work effectively if it tarnishes, but it just won't look as pretty. Some of you may have a copper bowl for beating egg whites. It is known for its ability to help stabilize an egg foam, as copper ions actually interact favorably with the proteins in the egg white foam and help them to be more stable. You can also create stable foams through good beating and then addition of small amounts of sugar near the end. It is not recommended to cook and eat lots of foods from copper. If we are exposed to it in high doses, it can become toxic. So again, that's why normally we don't eat directly from copper, and very rarely do we cook foods in containers that are exclusively copper. Cast iron is one of my favorite cooking tools. It is safe, it's very inexpensive. The downside is that it will rust if you don't use it carefully. It has to be washed and dried thoroughly, and it needs to be taken through a process known as seasoning. And I do have one of the videos I posted for you by Alton Brown walks through the steps of how to season a cast iron pan. Stainless steel is iron that has been alloyed with chrome and nickel to make it shiny and durable. It does not rust. That's why it's called stainless steel. It's more expensive than cast iron or aluminum, but again, it is very durable. It is not particularly effective at being non-stick, but again, very good for boiling water, heating soups, those kinds of things. And then tin is usually a liner, either in copper equipment or tools, or layered on steel as a liner for cans and canned products. It has a very low melting point, so it works effectively as a thin layer in cans, but again, not normally used as a cooking medium. We'll pause here and come back in just a minute.